Okay, this tutorial is going to walk you through some ways to start thinking about the combination of Dynamo and Revit in ways to parametrically think about form and information at the same time. So what we're going to do is create a conceptual mass, some mass floors in Revit, and think about those things as something that is parametrically linked between the levels that you created in the model as well as the geometry that you have, and then map some just basic information onto those mass floors so that you could start analyzing, say, the way that they're performing, either through daylight or views, say, out from the floors, which we'll try to cover in some future tutorials. So I've got a new architectural template open here in Revit, and I'm going to open a new Dynamo project over here to the right. And in Revit, I'm going to start off as promised just by making a new mass. I'm also going to make a new 3D view under the View tab. And this mass is going to be very straightforward, just a couple of different square objects. And I'm going to go to level 2 to make this second somewhat offset rectangular profile, and select both of them in the 3D view and hit create form. Here I can finish the mass. I'm going to go in level 2. Excuse me, I'm going to go back into that mass and edit it again. And I'm just going to pull this up so it's got some height to it, taking it up to around 100 feet. I don't think the proportions of these things matter a whole lot, except that you do want some multiple levels in here. And then I'm going to go into an elevation and create some new levels just by selecting level 2 and hitting array. And I'm going to make the floor-to-floor height here, say about 15 feet. And I'm going to make 8 of them. And let's go ahead and make a couple more. So maybe we have room for 11. And so these levels I'm going to use to actually create the mass floors inside of the conceptual mass. So I can select the conceptual mass, hit mass floors, and I'm just going to shift to select and then click the checkbox to make those mass floors on each of the levels that I just created. And here you can see now the mass floors that are done. So when once I've done this, when I was describing in the introduction of the video how we can start to think about the geometry being something that's parametric, these mass floors are tied to the mass. When I hit edit in place and hit ungroup, I can grab one of these edges of the mass and say pull it open so that it's more of a square geometry at the top, and then hit finish mass. You'll see that it goes through and recreates those mass floor shapes at the intersections of each of the levels that I have created. If you want, you can come in here to create under view and plane views, create floor planes to go with each of those levels that you've made. So with each of the levels that I have, this mass geometry is controlling the shapes of those profiles, and I can pull on faces, I can manipulate and kind of change this geometry depending upon whatever I might be looking at. So here we've got a geometric kind of parametric model, if you will, and over here in Dynamo I'm going to create an analytical variation of that same thing. So first thing I want to do is to get these mass floors brought into Dynamo, and I'm going to do that with select faces. So these Revit components, you can see here when you're typing in and searching for components, the kinds of things that it's looking for. So when you mouse over stuff, this gives you some good clues as to what the model might be looking for. And in this case, it's a Revit component. So when I put it in, and we've used this before, I can hit the select tab. You're going to see that it wants to select some of the mass faces as well. I'm going to draw a box to select the faces and then go around and deselect the faces of the mass itself. So what I'm looking for is for all these mass faces to have a plus symbol next to them, indicating that they are deselected and that I can't remove them from the selection. It looks like the bottom of this mass is also selected right now. So I'm just getting those mass faces selected, and then I can hit finish up here in the gray bar to indicate that I have selected everything, and all those mass faces now show up in Dynamo. I'm going to go to the geometry tab and then hit zoom to fit, and also hit the rotate so that I can pivot around this with the left mouse button and get a good view on all of my faces. So a lot of the components that we'll use in Dynamo aren't necessarily built right into the component. And there's a tab up here in Dynamo called Packages. And if you hit that tab, you'll see that you can search for packages. These are basically plugins that you can add into the components, add to create more components, increase the capabilities of Dynamo. I'm going to hit search for packages, and you can see that it syncs with the server offline to be able to add in components. And what I'm going to search for is Lunchbox. Lunchbox, you'll know from Grasshopper, as a component that's written by Nathan Miller, who has his own practice where he writes components and does computational design consulting all over the country. You can see, since I typed it in before, it wasn't coming up right away, but once it starts searching and syncs with the server, you can hit Lunchbox and it'll pop up here. You can hit the download arrow. It prompts you, are you sure you want to install? I'm going to hit OK. It's got Python components, yes I know. So I've already installed mine, but you shouldn't get an error like that. Once it's installed, out here at the main level, you should see that a Lunchbox package components shows up in the list. You don't have to restart or anything. This just comes right in. So what we're going to do is use a Lunchbox component that's also very useful in Grasshopper that creates quads on a surface. So I'm going to type in the word quad, and you're going to see here that there's this panel quad component that pops up. So with the panel quad component, it's looking for surfaces. I'm going to plug in these surfaces. I'm going to plug in these surfaces here. It seems like what just happened there was when I double clicked on the panel quad component, it actually was bringing up a tutorial or an explanation of the component. That's kind of interesting. Anyway, here now we can put in a number slider for the UV components. Please be careful here with how many U and V components you actually select. I'm just going to put in about 10 in each direction. If you go too high, because you have so many, it's going to create a lot of components all at once. You can see even at 10 that my computer's thinking quite a bit, and it's created a list of 6,000 components. Basically, it's dividing each of these panels into a 10 by 10 setup. If I mouse over here, the lower component, you're going to see that this already breaks these components down into a series of lists, basically tying back to the original faces that I've got coming out of it. We're going to want to flatten all that. You may not always want to do that, but in this case we are. We're simply just wanting to look at the underlying geometry in here. And you can see once I flatten it that it goes down to just 1,200 components. Here it's actually looking at all the points that are associated with each of the panels. 4 points for each panel going across. You get a whole variety. You get a lot more components. We may need a second one of these. We'll kind of put one off here to the side and wait and see. So what I'm wanting to do is actually just create a series of color. I want to color each of these quads based on their distance to a point in space. So we're just going to put a point component in, point by coordinates, and I'm going to make again some more sliders. So I'm just going to copy this one I've got and paste it 3 times. One for each of X, Y, and Z. And we'll plug those into this point component. If you don't put them in, the point just appears at the origin in your model. We're going to want to be able to control these later on, so that's why I'm going to go ahead and plug them in here. And then I want to get the distance from each of these panels to that point. So I'm typing in distance, and here you're going to see this distance, obtain the distance from this geometry to another geometry. You can see the inputs are geometry and other. In this case, the geometry that we're going to look for are our panels, and the other geometry is this point that we've just created. And when I finish that, you can see that I get a list of, I'm going to hit the pin here, I get a list of all of the distances from that original point to each of these panels laid out. And now, again, based on this distance, I want to create, I want to add color to each of the quad panels that I've created across this system. So I'm going to create a color gradient component. So type in the word color, and you can see there's a whole range of different ways of applying color inside of Dynamo. We're going to use this color range. So the color range has a set of default colors that are assigned to it, and you can see here that it has a list of values. What it's looking for is a list of values between 0 and 1, which is the range that we're assigning, and these actual values, so there's indices which sort of create the boundary and then the value here. So the distances is what we're going to use to assign these, and you can see that the distances range have quite a big range, and in fact we can put in a domain component. And the domain here again is a Lunchbox component, and it gets the domain from a list of numbers. So if I put that Lunchbox component in, here are my numbers, which are distances. And the domain, oh, it's still split out into lists. So as I had kind of thought, we need to flatten. Oops, that's our problem. I did not use the flattened version of our geometry. So I'm going to assign that flattened geometry. There's our list. And we have now the Lunchbox domain is giving me the lowest number, which is 0. That means that there is one panel that is actually touching the point, and then another one which is the maximum distance, which is 148. So that domain, we want to actually remap that domain, the numbers, the numeric values, we want to remap that range so that it matches the 1 through 0 that we want for the color range. So you can see there's a remap component that we're going to use for this. It's going to take these distances, which are our numbers, and it's going to reassign them between 0 and 1. So the default definitions here are 0 and 1. And when I look at the list of numbers, I'm just mousing over here, you can see that it's got 10 decimals, but in essence it's remapped all the values. So the relationship is still the same between them, but that they're between 0 and 1. This list of components goes into the values for the color range. And the output is 1200 RGB colors that are aligned to this range of components. And again, that comes back to this, the distance between the geometries. Now the nice thing here is that this flattened list of all of our panels and this color range are organized exactly the same to one another, right? So the list of my panels is actually oriented to the list of these colors based, again, on the distance to this point that we put into the space. So to apply these colors, we're going to put them on using, gonna again pull up the color component. Actually, I think we have to type in the word display. So we're gonna display the color by geometry color. So this is looking, again, you can mouse over it and see that it's looking for geometry and color, and the output is simply a display of those colors. So our geometry is this flattened set of panels, and the color is coming out of this color gradient. And you can see here, I am having this issue with the flattened version of the component that I was concerned with. And I think what we need to do is flatten this list one more time. So I'm going to take the flattened component, You can see automatically once I flatten it again, for some reason it starts to work. I'm going to go ahead and put this fully flattened version in there and into the geometry distance too. There's something fishy that's going on because I didn't even have to connect the flattened geometry to get the colors completely going, but it seems to be working at this point. I'm going to select a bunch of these and turn the preview off. I'm going to go through and turn the preview off on these quads so that I'm left with, and on these original faces, so that I'm just left with the color range moving through. And now to get a sense of how this is working, if I start moving my point up in the Z direction, you should see a response to the color gradient as you move through, as you move the point, which is moving vertically up through your tower. The distance to that point is changing the colors of each of the different quads on that panel. There you can see the point just popped out of the side of the tower. You can visualize it. Now again, what I was trying to point out is that we can still come back here to this original geometry that I've got, and I can select, I can hit edit in place and grab an edge and start pulling on that edge to change the profile of the geometries. Hit finish mass. The masses update here in Revit, and you can see when I mouse over here in Dynamo, it immediately starts spinning and it's recalculating those mass shapes. So what I've got is a model now that's responding to components that are numeric and analytical here on the Dynamo side, and over here on the Revit side are actually geometric. So really what we can think about it is a parametric way of thinking that isn't just about analysis and isn't just about geometry, but could be both. And I think part of learning the best way to operate inside of Dynamo is understanding this relationship, understanding how to rely on geometry that sometimes is coming from inside of Revit and sometimes is coming from inside of Dynamo. Okay, that's all for this tutorial. Thanks.